In this section, we will take a look at adding and subtracting rational expressions. For now, we will keep the denominators the same. We will consider unlike denominators in the next section. The process is similar to adding fractions, and as with fractions, combine the numerators and place over the common denominator. But because we are working with polynomials, our numerators could be more than one term, as they are here. So we have to be very careful with that subtraction, since we don't just subtract the first term, but all of the terms that make up that numerator. So to play it safe, I recommend writing out the second step with parentheses around all of the numerators. This reminds me to distribute the negative to both terms of that last numerator when I rewrite it as addition. So dropping the parentheses on the first two numerators, distributing the negative on the last one, we will then combine like terms. Now, before we walk away, there is a chance the denominator factors and that 2x plus 3 is a factor. You might try factoring the denominator with the assumption 2x plus 3 is a factor. Because of the numerator being prime, the common factor can't be other than that factor. So sure enough, it's a common factor. Expect to need to reduce many of your problems. Here are the steps for adding rational expressions with unlike denominators. This process should sound familiar since it is exactly what we do to add fractions. We will address adding rational expressions with unlike denominators in the next section. But before we move on, let's review how to find the least common multiple of the denominators. That way we will be prepared in finding the least common denominator. These steps should sound familiar since it is what we do when we work with fractions. But I bet we will find working with polynomials to be more work. And as you can see, we start by completely factoring all of those polynomials. The least common multiple includes all of the different factors with the largest exponent you have on any one of those factors. A common mistake is to total the exponents of a factor. Again, it's the largest exponent, that factor, that we select. For practice in finding the least common multiple, assume these three factors are the denominators. We start by factoring. The first factor is prime. The second has a common factor of 4. We will need to prime factorize the 4. And for the last factor, prime factorize the 6. With everything completely factored, we write down the different factors we have seen. Now focus above the line on this slide. Your different factors are x minus 7, a 2, a 3, and x. Write these down to start your least common multiple. And then include the largest exponent on any one of these factors. Only the 2 has a power higher than 1. Multiply your constant factors together for the least common multiple. Here again we start by completely factoring. Notice how the third polynomial doesn't have the polynomial in descending order and how the squared term is negative. We will want to factor out a negative before we start factoring. The first two polynomials are easy to factor, and as for the third, check out the bottom of the slide. I factored out the negative first, switched the two terms, and then factored out the greatest common factor. When we write down the different factors we have for the least common multiple, you can ignore the negative since we will have a way to take care of it before this point. The different factors are y plus 3, y minus 1, y plus 2, 3, and y, where the exponent on all of these is 1. This product is the least common multiple. I included the negative for the least common multiple, but again, we will have a way to take care of it so we won't have to worry about it.